Welcome, ladies and gentlemen. Today we're going to be evaluating functions and understanding the graph of a function. Our learning targets today, we want to be able to read functions written in function notation. That's going to be very important throughout this year. We want to be able to evaluate functions accurately. And we want to be able to determine if a relation or a graph represents a function. So please make sure you have all of these learning targets in your notes. Alright, we're going to start with function notation. Often function rules are written as y equals 3x plus 4, y equals something. The y is going to be replaced with the name of the function. So please make sure you get this whole slide in your notes, ladies and gentlemen. It's very important, okay? First, we're going to talk about the f. The f is going to be the name of the function, okay? Whatever letter is out in front is going to be representing the name of the function we're working with. The x is going to be our input value. What number are we going to put into that rule? And the 3x plus 4, this is the rule of the function. Okay? Now, if we look at this right here, the f and the x, I'm going to show you how to read this. There's two different ways. The first way we can say this is the value of f at x. Or we're going to say f of x. We're just explaining the function name and what value we're plugging in for it. Okay? Now we're going to do a few problems using new function rotation. So we're going to be evaluating these functions given the rule. So we're going to work with example A first. A says f of x equals negative 3x plus 7. We need to evaluate this when x equals negative 2. So what that means is wherever there's an x value, we're going to plug in negative 2. So now this is going to say f of negative 2 equals negative 3 times negative 2 plus 7. Now this is very important. This is just the name, so it's going to stay that way all the way to the end. We're never going to change it after we put in our input value. So this is still going to be f of negative 2. And over here on the right, we're going to simplify. So negative 3 times negative 2, and we're going to get 6 plus 7. And then we're going to get our final answer. So it's going to be f of x. So the value of f at negative 2 equals 13. So whenever x is negative 2, our answer is going to be 13 for this rule. We're going to come over here, we're going to do the same thing. We're going to plug in negative 2 wherever we have an x. So we have g of negative 2 equals negative 2 squared plus 2 times negative 2 minus 10. Now we're going to simplify this. We're going to keep our g of negative 2 equals negative 2 squared, so negative 2 times negative 2 is 4, plus 2 times negative 2 is a negative 4, minus 10. So when g, the value of g at negative 2 equals, this right here is going to give me 0 minus 10. So g of negative 2 equals negative 10, which is saying whenever the x value is negative 2, my answer is going to be negative 10. All right, I have two more examples like this for you guys to get in your notes. Make sure you guys just had those in your notes, please. Now these next two, we have to get our notes, but they're asking us a little bit different question here. It's just a different way to evaluate. They say f of x equals negative 3x plus 7, but now it says find f of negative 4. Remember, f of negative 4 means the value of f at negative 4. So what that means is all I need to do is plug in negative 4 for my x's. So f of negative 4 equals negative 3 times negative 4 plus 7. Simplify this. F of negative 4 equals 12 plus 7. F of negative 4 equals 19. and that's going to be our answer. So when x is negative 4, my answer is going to be 19. Come over here, the same thing. Now we want the x to be negative 1. So anywhere there's an x, we're going to type in negative 1. So g of negative 1 equals negative 1 squared plus 2 times negative 1 minus 10. G of negative 1 equals negative 1 squared, so negative 1 times negative 1 is 1, plus 2 times negative 1 is a negative 2, minus 10. Order of operations, we get g of negative 1 equals 1, negative 1, because it's going to equal negative 1 minus 10. Now, the value of g at negative 1 equals negative 11. So when x equals negative 1, my output, my y value, will equal negative 11. All right, there's our functions. Function notation. We're going to be using this all year, so it's very important that you understand it. Okay, ladies and gentlemen? All right, now we're going to move on to some graphs. Now, I don't want anything on this slide to be written down, so just follow along with me, okay? We're going to consider two different graphs. We're going to gather information about people and their heights, and we're going to make these two graphs. Our first graph is going to represent the x value being a name and the y value being our heights. The second graph is going to represent the height being our x value and the name being our y value. So our input and our output. Now, if we look at this first one, we have to determine if it's a function. Remember, a function has exactly one input has exactly one output. If we look here, we have that. This is a function because the x value has only one y value. If we come over to our second graph, when we do the height and the name, this is not a function because the x value of 5 right here has two different values for y. Okay, so this would not be a function. Now, when we're looking at graphs, we're going to use this rule. It's called the vertical line test. Most of you have probably used it before, but I still want this to get into your notes, please. The vertical line test is a relation is a function if the vertical line drawn through its graph passes through only one point. That's very, very important. Only one point, okay? And it's a vertical line. So in order to do this, we're going to take a pencil and move it from left to right. If it crosses more than one point, it is not a function. So have this written down in your notes, please. I'm going to go over 3 examples. You don't have to put any of these in your notes, but I do want this part right here to be in your notes. All right, here we go. We need to determine if this is a function. Well, we've talked about this one already. If we take our pencil and we do our vertical line test and we move it across vertically, we'll see right here at 5 that it touches 2 points. So we know that this graph cannot be a function. All right, here comes the second example. Would this graph be a function? If we take our vertical line, so we're taking our pencil and we're moving across left to right, we're going to see that it only touches our graph at one point each time. So if we ask ourselves, would this be a function? We're going to say, yes, it only touches our graph one point at a time. Now for our last example here, we're going to look at this graph and ask ourselves the same question. Would this graph be a function? We're going to take our pencil, do our vertical line test. Go straight across. Right away, it's only going to touch at one point. But if we continue on, we'll see here that it touches 2 points at the same time. So if that happens, we know that this graph cannot be a function. This one is not a function. Can only touch one time to be a function, ladies and gentlemen. All right, this is all I have for you today. I hope you guys have a wonderful day, and I will be seeing you later. Bye.